Hey folks, in this video we are going to learn about some simple looping structures. So let's begin. So to begin with, a loop is a control structure that allows us to repeat instructions slash code. Brilliant. There are different types of loops that we can use in Python. And the one that we're really going to focus on, at least for the next while, is called the while true loop. So is a control structure that will repeat any code within it. And when I say within it, I mean indented. Forever, while it is true. This is why we call it a while true statement. Let's look at an example of what I'm talking about. So I will write while true. I hit enter. Things are indented. We're looking pretty sweet. This is line 1. And print, this is line 2. Now just double check that everything's pretty good. I've got my semicolon here, which indicates this control structure. And both of these statements are indented within it. So they belong to this control structure and they are lined up by the looks of it. So if I hit run, we are getting some code. And it is repeating. It will repeat forever while my laptop has a battery. Because this statement is true, so we're just going to keep repeating it over and over again. Alright, so let's just stop that. Now, some things to sort of watch out for that can be a bit of a problem is the common ones. It's a control structure. If my semicolon's gone and I hit run, it's not going to work. But we do get an error message. Okay, it's line 4. We're missing a semicolon. Let's whack that back there. We could also have problems with our indentation. Super important to get it right. But let's say it's not indented. Expected an indentation on line 4. Line 5 on line 4. Something's a bit off there. So we hit the tab. Life's looking pretty good. Maybe it's slightly out of order there. Maybe I hit a space, so these are not in line. I could hit run. Unindent does not match outer indentation level. Or you could even get the old classic unexpected indent, because it thinks that, like, why are you indenting it a second time? So just that's sort of to watch out for. Now, while this is true, this will run. The converse is also true. If I was to type false and then run, nothing will run because this line is false. Okay? So we're using the Boolean values of true and false. And we can link these up. We can be a bit sneaky. We can make variables and we can use them to tell us when the loop should run or how long it should run for and that sort of thing. And we're going to start with a variable. We'll call it game state. And we'll assign it the Boolean value of true. And so rather than saying while true, we could say while game state is true, we'll run that program. And this will run, sure. But I'm sort of doubling up here. Okay, and if we remember from our Booleans, like, we don't actually have to compare them or to other values. We can just call upon the variable if we've assigned it a Boolean value anyway. So we can just delete this and we can run it and it will run fine. Because this is saying, while this is true, print this. And we know it is true, etc. And we could also do the same. We could make it false. Stop and rerun. Nothing will run because the line is false. Now again, classic debugging. What could go wrong here? The old classic, maybe your variables just don't match. Maybe I put a capital letter there and this one not. And you'll get that it's not defined, that sort of vibe. And maybe because we're using Booleans, it's important to remember they need to have capital letters. If I don't have a capital letter, something's off there as well. So you just got to watch out for that. Brilliant. Now, we could also use integers. We don't just have to use strings. and integers are pretty good as well for this kind of thing. So let's start with something simple. I want to make a program that's going to count. It's going to count up to 5, and it will finish when we do that. And you could say print 1, print 2, print 3, print 4. I'm just going to be lazy. I'm going to finish at 4. I can't even be bothered. Okay, and look, we get our 4 numbers. Awesome. But I don't know about you, I really didn't enjoy retyping all of that over and over again. And if I wanted to make a program that counts to like 1,000, whew, disaster. So let's use our while loop. So I could say count equals 0. And we can say while the count is less than 5, print, we would want to print the count. And then we would, oh my days, what is going on here? What in Sigma? Okay. Count plus equals 1, and print the counting is done. Okay. Let's run this, and then I'll unpack what's going on. Count, 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 the count is done. Oh, that's what I've done wrong. I've made it a string. I haven't called the variable. You idiot. Alright, now we'll run it. Okay. 0, 1, 2, 3, 4, the counting is done. Okay, let's unpack why this code works and why it's efficient. But to help us understand this is I'm going to do a little bit of extra debugging. So this is sort of an optional thing for you guys to do, but it will be sort of helpful. So where all these numbers are, I could hover over my mouse, and it's like a red dot or something like that. And what you can do is you can click it, and I'm going to click it where my code starts. This red dot is called a breakpoint, and you only need 1 in your code. And what will happen is once your code hits the breakpoint, it will stop until we let it go line by line. So it's a very useful tool to slow things down. So I've made a breakpoint, and I'm going to come over all the way, not to run, but to debug. And it's a picture of a bug. So if I click this, and I'm going to move this window away, and I have this debug window here. Okay. Now it's at threads and variables, and I'm going to click on console. Brilliant. I'm at the debug. I'm at the debug window. And I'll make it a little bit bigger. Cool. I'm in the debug window. I'm running debug. I've got my breakpoint. It's at this line. It's reached this point. It has highlighted the line at where we are at. Okay. And what I can do is I can click this button here, step over. You can also hit function F8. And what it will do is it will jump 1 by 1. Instead of running all of the code, it will jump it. And what's happened is, okay, my count is 0. And we've hit our while loop. So let's keep going. Print, count, it prints it, 0. And then we're at this line. Count plus 1. It executes that. Now my count is 1, because 0 plus 1 is 1. And notice, I didn't go straight back. I didn't go to this print the counting is done. The counting is not done, although it has just triggered the counting is done. Don't know why that happened. Let's just restart that. Stop and rerun. Okay. Count, while count. I think it's because I went my mouse over it or something like that. Yeah, surely, right? Yeah, okay. It's gone back to the while loop because it's still true. So we're just going to keep repeating this code. We are not going to move on to other parts of the program yet. It's not accessible. So we'll keep going. So print the count, 1. Add 1 to the count. Now our count's 2. We keep repeating the loop, the while loop, because it's still true. Keep going. Our count is 3. 3 is less than 5, so we keep repeating. Add 1. 2. Print. Add 1. Aha! Now we've got to this point. The count is 5. 5 is not less than 5. 5 is 5. So this statement is now false. And so what will happen is it will skip that loop. And we go to this final line and we execute it. The counting is done. And if you were to do, say, an extreme example, right, and like why this would be sort of important. If I didn't use the debug tool and I just did a generic one, I could say while count is less than, say, 1,000,000, okay, and I run it, it runs it very fast. The counting is done. It's just counted to 1,000,000 in like a second or two. This is because like a Python program or any general computer program runs very quickly. It's very good at going through these lines. And as you saw, it just did 1,000,000 lines of code in a second. So if you ever, particularly with loops, but you could use this tool for like your if and elif control structures, you can put your breakpoint just to slow things down and just say like, okay, is this actually doing what I wanted? So it's a very useful tool in terms of that. And the other thing that could be sort of useful for this is like when we start nesting these sorts of things. So you could do like an extreme example. This is the first line. And then I could nest another while true statement within this. Okay? Because why not? YOLO. This is the second line. And then I'd even nest a third one if I want. Crazy. This is the third line. Like this. Okay? And if I was to run this code, alright, I just get what appears to be this is the third line over and over again. And that sounds a bit weird because you're like, well, shouldn't I have printed my first and second line as well at some point? Something's a bit off. It's because the program has just literally run 1,000,000 lines of code. So I'll put my breakpoint. I will click debug. I will go to this debug window, which is just under the run terminal, and I'll click on console. Okay, and let's have a look at what happens. So I'll step over. Okay, while true, I don't even need to count, whatever, doesn't even matter. While true, the statement is true, print. Okay, this is the first line. Now we're up to this while true. Is this true? It is. So we'll go over here. This is the second line. Okay, so it does print that. And then we're up to our third while true. This is the third line. And it's just going to keep printing the third line because it's stuck in this final loop. So that's just something, again, like, especially with nesting and things like that, can get a bit confusing. So use that debugging tool just to isolate what's going on. Yeah, best of luck.